Hello everyone, welcome to Chemazon-Complete Chemistry. So whenever we study, we many times come across questions which are very basic, but we don't take an extra effort to go back and check why the things are the way they are. So in this new question series that I'm starting, that is called as Interesting Question Series, we will see some very important uh, and most interesting questions, and also we will try to understand or clear some misconceptions that are prevailing. So our today's topic is nothing but why study stereochemistry. So we had seen all the different theoretical techniques by to find out whether a configuration is R or S using CIP rules, or whether a compound is optically active or not. So what is the practical application of doing all these things? What is the practical application of knowing whether a compound is optically active or not, or whether the compound has an absolute configuration of R or S? So, so we know that this we had discussed in the last video itself, that one of the enantiomer of limonene is present in nothing but oranges, whereas the same molecule but of different stereochemistry, that is the minus limonene, that is the other enantiomer which is present in lemon. So although more or less same molecules, only the stereochemistry is different. They are present in two different natural products. One is present in oranges and one other is present in lemons. Similarly, there is another example of carvone where one of the enantiomer is present in spearmint leaves, or nothing but called as mint leaves, and the other enantiomer of carvone is present in nothing but caraway seeds, or this is also called as jeera in Hindi. So this is very interesting that the same molecule, just the change is nothing but the stereochemistry is present in different natural products. And now let us try to understand the applications of stereochemistry in medicine, which is very important. So the first example is the drug ibuprofen. So this drug ibuprofen has again two enantiomers, one is S and other is R. So the important fact to be noted is that the S enantiomer of this ibuprofen is nothing but used as a painkiller, and it is also used as anti-inflammatory drug, which means it is used to treat inflammation. Whereas if you see, the R enantiomer is nothing but inactive. Let us see one more example of this timolol or timolol. Again, the S enantiomer here is used to treat angina, or this is nothing but, in general terms, it is called as chest pain, and also it is used to treat high blood pressure. But if you see, the R enantiomer of this timolol drug is nothing but used to treat glaucoma. So what is glaucoma? Glaucoma is nothing but a eye condition where the nerve connecting the eye to the brain is damaged. That is nothing but the optic nerve is damaged. So this drug, that is R-timolol, is used to treat that condition, or it is useful in treating this disease called as glaucoma. So you can see the same drug, S enantiomer has different properties and R has completely different action or drug action. So similarly, there is one more example where this R-penicillamine is used to treat chronic arthritis, or what is arthritis? Arth here means joint, and itis means nothing but inflammation. So this drug is used to treat inflammation that is caused in our joints. And whereas this S enantiomer is nothing but toxic in nature. Similarly, S naproxen, this drug, is anti-inflammatory in nature or used to treat inflammation, whereas the R enantiomer is a liver toxin. So now we have become aware of what are the different properties of R and S enantiomers of different drugs. Now the question is, first question is how to experimentally find out whether a compound is having R or S absolute configuration. So when I give you the compound, I give you the structure of the compound, it is very easy to use CIP rules or Kahn-Ingold-Prelog rules to find out RS nomenclature. But suppose I give you a drug, an unknown drug, and if I tell you take this drug and find out whether it is R configuration or S configuration. So how do we basically do that? So for that, there are two instrumental techniques that can be used. One is X-ray crystallography. That is, we can do X-ray studies and find out whether the absolute configuration is R or S. And the second technique that can be used is nothing but NMR, or nuclear magnetic resonance spectroscopy. So these are the two techniques that can be used to find out whether the absolute configuration is R or S. Now the second question is how to experimentally find out. Suppose I give you any sample and I don't give you the structure, but I tell you to experimentally find out the optical activity of the compound, whether the compound is optically active or inactive. So the answer to this question is nothing but the next video, which we are going to discuss what is optical activity. We will also see what is optical rotation and how do we find out experimentally. It is nothing but done with an instrument called as polarimeter. So here we come to the end of today's video, and in the coming videos we will be discussing some very important topics of stereochemistry, that is what is optical activity, what is optical rotation, and how do we make use of polarimeter to find out whether a compound is optically active or not. And in this question series I will be posting more such interesting questions, which normally while studying we might have a question in our mind, but we don't go back and find out what is the exact reason for that. I hope you like this video. Thank you. Please subscribe to our channel and don't forget to press the bell icon. Thank you.